So the next part of linear relationships and slope would be in module 8, lesson 8.5, and we are going to work on slope intercept form today. Our learning target, I can write equations of the form y is equal to mx plus b when given a table, graph, or verbal description. And for vocabulary, we are going to talk about the initial value, the slope intercept form, and the y-intercept. So let's go ahead and first talk about the slope intercept form. And this is basically for your non-proportional linear relationships, okay? Now, till yesterday, we were working on proportional linear relationships, and we had learned about the equation in that, which was for the proportional linear relationships. My equation is y is equal to mx, and where m was the slope, unit rate, constant of proportionality, and all that. Okay, so that is a proportional linear relationship. Now, for a non-proportional linear relationship, all right, uh, all we are doing is adding on the y-intercept. And so this is called the slope-intercept form also. And so the non-proportional linear relationship, the first part is exactly like this. So we have y is equal to mx plus b. And this is my slope intercept form of a line. So non-proportional linear relationships can be written in the form y is equal to mx plus b, and this is called your slope intercept form. Okay, so this is called a slope intercept form. So in this, my m, again, just like m was the slope over here in proportional, m is the slope in the non-proportional also. And b is the y-intercept. Where does the line cut the y-axis? That's basically what y-intercept means. Okay, so when an equation is written in this form, again, m is the slope, b is the y-intercept, and the y-intercept of a line is the y-coordinate of the point where the line is crossing the y-axis. So let me go ahead and show you a graph. So let's look at this graph over here. Okay, and so as you can see, the equation is written in the form of y is equal to mx plus b, and we can see the m is the slope. So you have your rise over run, so 1 over 2, which is 1/2, and that's the slope. All right, plus where is it crossing the y-axis? As you can see, it is crossing the y-axis at 1. So look here, and this is your y-intercept. Okay, so where it is crossing the y-axis, that is your y-intercept, and that's how we have this one, because this is 0, this is my 1, so there you go, plus 1. Okay, and then we have the slope here. This is your rise over run, and so we have 1/2. So y is equal to mx plus b, where m is 1/2 and b over here is 1. All right, so let's go ahead and quickly discuss what happens in a non-proportional linear relationship. Let me show you this. So in a non-proportional linear relationship, the graph passes through the point 0b here. Okay, crosses through the point 0b, which is here. And this is the y-intercept. And you can use the slope formula to derive the equation of a line in slope-intercept form. So what is my slope formula? My slope formula, m is equal to y2 minus y1 over x2 minus x1. Right? So my it's going to be my y1, as you can see, is b. Right? So I'm going to use this formula. I'm going to say x1, y1 is 0b. This is x1, this is y1, right? And then my x2, y2 is this one. x2, y2 is my xy. All right? So if I'm writing this formula, I am going to do m is y minus b, right? Because y2 minus y1 will be x minus the 0. X minus the 0. And so therefore, what am I going to get? I am going to get y minus b, because here, I'm going to get y minus b over x minus 0 is x. And then I am, and of course this is equal to m. All right, so this is equal to m. And then I am going to simplify, and I am going to do the multiplication property of equality. This is y minus b is equal to mx. And then I am just going to use the addition property of equality, plus b plus b. So y is equal to mx plus b. Right? So this is how we derive that. Now, let's do an example. And let's look at this. It's saying identify the slope and y-intercept of the graph of the equation. So to identify the slope and y-intercept of the equation, we are going to write the equation in the form of y is equal to mx plus b. We know that m is the slope. We know that b is the y-intercept. So next, we are going to take this equation, which is y is equal to 2/3 x minus 4. All right, so this is going to be like plus the minus 4. Let's put it this way, because b is negative 4. And that means it is a downward slope, right? So now what is the slope over here? The slope is going to be this part, because m is the slope. We have talked about this. And this is my y-intercept, right? So my slope is 2/3. And what is my y-intercept? This is going to be negative 4. Okay, so that is going to be negative 4. So the slope of the graph is 2/3 and the y-intercept is negative 4. So why is the y-intercept negative 4 and not 4 in this case? So then an equation in slope-intercept form is written as y is equal to mx plus b. So the y-intercept is negative 4. That means that line is crossing the y-axis at negative 4. All right. Now, let's identify another one. So let's look at this one. And okay, so once again, identify the slope and y-intercept of the graph of the equation. So if I'm looking at this, we know that this is, because we have y is equal to mx plus b. This is my slope, right? So my slope is negative 2/5 or negative 4/10. So slope is negative 2/5 or as negative 0 and 4/10. So that is my slope. And what is my y-intercept? Here, because it's plus b, so therefore it is my y-intercept is going to be, if I was writing it in that format, it would be plus negative 1. So this is my y-intercept, which is b. All right, so slope is negative 2/5 or negative 4/10, and the y-intercept is negative 1. Now, we are let's look at this. Write the equation of a line in slope-intercept form with a slope of negative 3 and a y-intercept of negative 4. So once again, we are going to write the equation, and the equation is y is equal to mx plus b, where m is the slope and b is the y-intercept. So what does it say that the slope is? So instead of m, we are going to substitute the value. It's telling me that the slope is negative 3. So I'm going to write y is equal to negative 3x plus, what is my y-intercept? Here. So plus negative 4. And then I'm going to just simplify, and therefore y is equal to negative 3x minus 4. And that is the equation of the line. Let's do another one. Let's look at this one. And if I am to write the equation of this line in slope-intercept form, we have y is equal to mx plus b. What is the slope? Is 5. So I'm going to write y is equal to, instead of m, which is slope, I'm going to write 5x. Y-intercept is negative 7, negative 7. And then I am going to just put it in the simplest form. We have 5x minus 7. And there is my equation written out. Okay? So here you go. So let's look at this one. Writing equations in slope-intercept form from graphs. So you can write an equation in slope-intercept form. So let me just show this to you. Okay. So you can write an equation in slope-intercept form of a non-proportional linear relationship from its graph using these steps. So look, find the location where the line crosses the y-axis to determine the y-intercept. So look, this is where it is meeting the y-axis. This is the y-axis. This is where it's crossing over. And so this is going to be your y-intercept, which is negative 1. All right. Then we're going to find the ratio of the rise to run. So we're trying to find the slope of the line. So if you're looking at this one, this is the line. Here's my rise, which is 3. My run is 2. So my slope is 3/2, right? And then we are going to put it in the format of y is equal to mx plus b. So therefore, y is 3/2x minus 1. And that's all. Just looking at that, we are looking at where is it crossing the y-axis and what is the rise and run, and then we are substituting that value into the equation. So let's do a problem. So let's look at this graph over here, and we are going to write an equation in slope-intercept form. So if I look at this graph, I need to see where is my y-intercept. That means where is my line crossing the y-axis So I can see that it is here. Okay, so this is 0, this is 1, this is 2, this is 3, this is 4. So where is it crossing? It's going to be the y-axis is at 0, 4, right? This is my ordered pair. And so 4 is my y-intercept. Then we're going to find the slope. So we can see that this is a downward slope. So we are going to move down 1 unit because rise over run. So we are going down 1 unit and 2 units to the right. So it's going to be negative 1/2. Slope is negative 1/2, as you can see over here. Okay, so now once I have this, I am just going to write the equation in the form we have. What is the slope-intercept form? So y is equal to mx plus b. I am going to substitute the values. My slope is negative 1/2. So y is equal to negative 1/2 x plus, where is the y-intercept? It is at 4. So we're just going to substitute those values or replace those values into this equation. All right, so the equation of the line is y is equal to negative 1/2 x plus 4. Let's talk about writing equations in slope-intercept form from verbal descriptions. So let's look at this one. And we're going to learn about what is initial value. All right. So when an equation in slope-intercept form applies to a real-world situation, the slope represents the rate of change and the y-intercept represents the initial value. So that's what initial value means. Okay. Now, bamboo is one of the fastest growing plants on earth. Suppose a bamboo seedling is 5 centimeters tall and grows at a rate of 6.5 centimeters a day. We are going to use this knowledge because it's a real world situation to write an equation in slope intercept form. Okay, so we're going to find the slope and y-intercept. So the slope in this case all right, so my slope is going to be, all right, let's look at this one. It's going to be the change in height, change in height over change in time, change in time. So if I'm writing m, what is my change in height? It is 6 and 5/10 centimeters. Okay, so m is 6 and 5/10 centimeters, and change in time is 1 day. 1 day. Okay, now if I'm looking at this, here is my slope, and then what is my y-intercept? Here. Okay, so my y-intercept is going to be 5 centimeters. 5 centimeters. And so now I'm going to write the equation in the slope-intercept form where I put y is equal to mx plus b. And I now substitute the values, and 6 and 5/10 over 1 is 6 and 5/10. So y is equal to 6 and 5/10 x plus b is 5. So here is my equation written out. All right, so let's do another example. And we are going to write this in the slope-intercept form. Okay, So let's look at this question. Um, So the student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. Write an equation in slope-intercept form to represent the total cost y for printing any number of shirts x. So we are going to find the slope and y-intercept, and the slope represents the rate of change or cost per t-shirt. It costs $5 to print each shirt. And the y represents, um, the y-intercept represents the initial cost of the design. So the one-time charge for the design is how much? It is $20, right? And this is for each shirt, this is going to be representing the slope. So the slope is $5. This is your slope, and this is going to be your one time, this is your y-intercept. Okay, so now we are going to put this into an equation in slope-intercept form. Y is equal to mx plus b. And so therefore, what was my slope is $5. So y is equal to 5x plus the one-time fee, which was how much? The initial cost is $20. So here is my slope-intercept form written out. And the equation that represents the total cost of printing any number of shirts is y is equal to 5x plus 20. And how would the equation y is equal to 5x plus 20 be altered if the cost to print each shirt was increased to $7? So if the shirt was increased to $7 instead of like the 5, how could I alter this equation? I'm going to rewrite it, and I'm just going to, instead of 5, what would I write? I would write y is equal to 7x plus 20. So if the cost was $7 instead of 5, this is what my new equation would become. Okay? So, um, next thing we're going to look at is learning to write equations in slope-intercept form from tables. Okay? So you can write an equation that represents a non-proportional linear relationship in slope-intercept form from a table of values. And then first we're going to determine, of course, the slope and the y-intercept. Then we're going to write the equation in the form of y is equal to mx plus b. So if I'm looking at this, this is going up, my x is going up by 2 and y is going up by 12. Okay, but let's look at this. So the slope or rate of change in the table, as you can see, if I had 1, if I had 3, if I had 5 in the table, instead of like jumping by twos like this, what would it be? Okay, so instead of 12, it would be going up by how much? It would be going up by 6 then, right? So if I'm looking at that, the slope or rate of change in the table is 6. And the y-intercept is going to be the initial value, which is 10. Um, so if I'm looking at this, is going to be y is equal to 6x plus 10. Okay, it would have been y is equal to 6x plus 10. And that would have been my equation. All right. So please remember once again, the reason why I'm saying 6 and not 12 is because what are we missing over here? We're missing the 1, 3, 5, right? So then if that is going up by 1, then this would be going up by 6 on this side. So let's do a problem with this. And here we go. All right. So we have this question where Amanda is reading a novel for her language arts class. The table shows the number of pages that Amanda has left after a certain number of hours she spent reading. You can write an equation in slope-intercept form that represents the data in the table. Okay, so let's look at this. And we're going to find the slope first. As the hours increase by, let's see, what is the pattern that we are noticing here? Okay, so we can see over here what's happening. This is plus 2, plus 2, plus 2, plus 2, right? So as the hours increase by 2, the pages left to read, what is happening here? This is minus 80, minus 80, minus 80, minus 80. So what is happening? It is, so as the hours are increasing by 2, the pages left to read decrease by 80. So we know what is slope. Slope is change in y over change in x. Change in x. So change in y over change in x. And so what is my change in y? This is negative 80, right? This is my change over 2. And so therefore, I'm going to simplify this, and I'm going to get negative 40 over 1. So what is my slope? My slope is negative 40. Right? So next, let's just look at this really quick. What does the slope represent in the context of this situation? And so the number of pages left to read decreases each hour. So that's what the slope is representing. Okay, so number of pages left to read decreases each hour. So now we're going to find the y-intercept. So we're looking at find the y value when x is 0. So when x is 0, here, let's look at this part. This part. Okay, so when x is 0, what is y? It is 360. So the y-intercept, or the initial value, this is going to be my y-intercept, is 360. Okay, so when x is 0, what is y? And that is telling me what my y-intercept is. And so now I'm going to substitute the values for slope and y-intercept in the equation. So if I have y is equal to mx plus b, I'm just going to substitute the values. What did I get as my slope? Was negative 40. So that is negative 40x plus, what is b over here? It is 360. So that is how I'm going to write it out in the slope-intercept form. And the equation that represents the data is y is equal to negative 40x plus 360. And so what does the y-intercept represent in the context of this situation? So in this case, the number of pages that Amanda had to initially read. And that's what the y-intercept is representing in this situation, right? So that's what this entire lesson is about. And please remember the difference between your proportional linear relationship equation and the non-proportional linear relationships. In the proportional linear relationships, which we've done in the past, you have y is equal to mx. But in this case, the y-intercept, in the non-proportional one, the y-intercept is added on. And so that is why it becomes y is equal to mx plus b. And using tables, using graphs or verbal descriptions, we are able, using the slope and the y-intercept, we are able to plug in into an equation form of y is equal to mx plus b. And that concludes our lesson for today. Have a great day.